Hey guys, good morning. Can you hear me? Hello. Yes, guys, can you hear me? Hello. Yeah, can you hear me? Can anyone please respond? Can you hear me, guys? Yeah. So let us start session. So yesterday class, yes, about interpreter and compiler discussed here yesterday's class. Yes. About interpreter compiler yesterday's class. Sorry. All basics were discussed. Yesterday's video not uploaded. Just a minute. Yesterday video. Let me check it. Yeah. Okay. Yeah. Yesterday's video. The interpreter versus compiler yesterday topic discussed. One second. Yeah, with some busy work, office work, I could not share yesterday's. 30 AM. Just 1 second. Someone giving some disturbance, voice, background noise. Mute everyone. Okay, fine. So yesterday's session. Yeah, after finishing this class, I'll share it. Yesterday's session also. Fourth session. Yes, 16th. Yesterday, 17th. Okay. Yeah, let us start today's session. Yes, today topic. Yes, yesterday. Yes, interpreter compiler, fourth topic. Yes, today topic about Java features. Yes. Yes, fifth day. Yes, previous classes, all these basics completed, interpreter compiler also completed, Java depends on compiler as well interpreter. So this topic is completed. Yes, today topic is about Java features, features of Java. Features of Java. So features of Java. Features of Java. See, day 2. See, this is a day 2. Yes, this one, right? Yes. So there are features. Yes, to understand these features, we discussed about basics in last 2 classes. Yes, for the purpose of these features, to understand all these basics, to understand all these basics, to understand all these Java features, we have discussed about some basics, Java software basics, right? To understand all these things, basics completed. Now you can understand Java clearly. Yes, all the basics. So all the basics like all the basics like system software, application software. Next about OS. Okay, next low level language, high level languages. Okay, yes, source code, binary code, and about Java. Yes, interpreter and compiler. Yes, Java introduction. So this is completed. Now you can understand Java features very clearly. Now you can understand Java features very clearly. Now you can understand Java features very clearly. You can understand Java features very clearly. You can understand Java features very clearly. Okay. Yes. See, first one. Yes. Independent platform. Yes. Java is an independent platform. Yes. What does it mean? Yes, what does it mean? What does it mean? Because Java is an independent platform. Java is independent platform. What does it mean? So what does it mean? Java is independent platform. What does it mean? Okay. So Java is independent platform. What does it mean? Java is an independent platform. What does it mean? Here platform means OS. Platform means operating system. Platform means OS. The platform means OS. Platform means OS. It's an operating system. Okay. Yes, independent platform. Yes, Java is independent platform. So Java is independent platform means Java program can run on anyways. Java program can run on anyways. So Java is independent platform means Java program can run on anyways. Java is independent platform means Java program can run on any application. Okay, Java is independent platform means Java program can run on anyways. Okay, Java is independent platform means Java program can run on anyways. Okay, fine. Now question is here, how Java made us independent platform? Question is, yes, see independent platform means Java program can run on anyways. That's okay. That's okay, fine. How Java made us independent platform? How Java made us independent? Yes, independent of platform. So how Java made us independent platform? Yes, let us answer this question. Yes, how Java made us independent platform? Yes, to understand this one here, first of all, we need to about exe file and dot class file, the differences. Yes, if you know about exe file dot class file, then easy to understand this topic. Let us see about exe file dot class file. So first about exe file. First about exe file. First about exe file. First about exe file. Exe file. Okay. Here's some question for you guys. Some question. Yes, some question for you guys. Exe file prepared. Exe file prepared. Exe file. Some question. Exe file prepared on Windows OS. Exe file prepared. Exe file prepared on Windows OS. Can I run on Linux OS? Okay. Question is exe file prepared on Windows OS. Can I run on Linux OS? exe file prepared on Windows OS. Exe file prepared on Windows OS. Can I run on Linux OS? Yes, answer. Tell me guys. Exe file prepared on Windows OS. Can I run on Linux OS? Anyone can you answer this question? Anyone can you answer this question? Exe file prepared on Windows OS. Can I run on Linux OS? Anyone can you answer this question? Very simple question. Simple question asked. Exe file prepared on Windows OS. Can I run on Linux OS? Can I run on Linux OS? Yes, what's happened? Yes, no idea. No, 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 no. Reason? Yes, reason. Yes, reason. Exe file OS dependent. Exe file is OS dependent. OS dependent. Exe file reason. Exe file is OS dependent. Reason. Exe file is OS dependent. Exe file is OS dependent. Reason. Exe file is an OS dependent. Yes, now immediately question, why exe file is OS dependent? Why exe file is OS dependent? Why exe file is OS dependent? Yes, why exe file is OS dependent? See here, so reason exe file is an OS dependent. Why exe file is OS dependent? Immediately question, why exe file is OS dependent? Why exe file is OS dependent? So why exe file is OS dependent? Yes, For this purpose, yes, we should have to answer this question. Yes, we should know about exe file. Yes, let us see about exe file. About exe file. Okay. See, for example, here, for example, about exe file. Suppose, for example, here, for example, C program exe file, prepared, C program exe file prepared on Windows OS, then it contains what? For example, C program exe file prepared on Windows OS. For example, C program exe file prepared on Windows OS, then it contains what? Yes, then it contains binary codes for C program, binary code for our C program plus binary code for C program plus binary code for C library, binary code for C library plus binary codes for OS library, binary code for OS library. That's it. Okay. Yes, C program exe file prepared on Windows OS. C program exe file. Prepared on Windows OS. Then it contains binary code for C program. Binary code for C program. Binary code for C library. Binary code for C library. Binary code for C library. Binary code for C program. Binary code for C library. Yes, binary code for Windows OS library. Yes, let me show practically what are these things here. C program exe file prepared on Windows OS, then it contains binary code for C program. So what does it mean? So what does this mean here? Yes, binary code for C library. What is this? So binary code for OS library. What is this? Let us see about it. Okay. Yes. See. Let me start. Yeah, this is C program, right? Compiled, success, run it. Yes, executed, fine. Working fine. See, yesterday discussed about compiler. Discussed about compiler topic. Now, C, turbo C, yes, bin folder. Okay, so bin folder. Yes, bin folder. Test. Here, just one second. Let me delete all the old files. Delete and delete. Yes, not test.c. Okay. Yes. File, save, test.c. See this, set test.cpp. 1050m, just now saved. CP file. So 1810, 1050m, just now saved. So this is our C++ program. This C program or C++, both are same here. Now okay, let us see backend. Yes, let us compile. Yes, compile. See, when you compile here created one file, 3D object file, right? 3D object. See 1810, 1050m. Yes, properties. Let us check the properties. Yes, it's a .obj, means object file. So what is exact this .obj? This obj file contains what? This obj file contains binary code for C program with this part. So binary code for our C program. Okay, binary code for C program. Okay, whole this code converting into binary code and write into that object file. So binary code of your C program, binary code of C program, binary code of C program. Correct. So all this code converting to binary format and writing to the writing to object file, writing to object file. Just start to use object file. That's okay, fine. Next, here apart from this, yes, so these are C library. So these are C library. These are C library. These libraries are having, these libraries are also having its own binary codes. These predefined library also having binary codes. Predefined library having binary codes. And complete program for the C program binary code is object, the test.object file. Okay, yes, next. Now run it. When you try to run it, now it will create exe file, right? When you run this exe file, see that exe file created. Yes, application means exe file. So dot exe file created, dot exe file created, dot exe file created, right? So this exe file contains what? A C compiler creating exe file. How it's creating exe file? See, to create exe file, C compiler will take the object file for our C program, means binary code for C program. Test.obj, it contains binary code for C program. It contains binary code for C program. Yes, binary code for C program. Plus, next binary code for C library. C library. Yes, std data quantity data. For this library files, binary code. So these library files also having its own binary code, right? Okay, binary code for the C program is a test.obj file. So this file plus binary code for C library, binary code for C library plus binary code for OS library, OS library. Previous class we discussed, at the beginning classes we discussed about OS library. This is a OS library. Yes, I'll show now. OS library I'll show. OS library. So here this is OS library. By linking all of this in generates exe file. By linking all of this in generates exe file. Okay. C program prepared on Windows OS. C program exe file prepared on Windows OS. Then it contains binary code for C program. So first binary code for C program. Okay. Next plus binary code for C library plus binary code for Windows OS library. By linking all of this in generates exe file. By linking all of this in generating exe file. By linking all of this in generating exe file. Okay, by linking all of this in generates exe file. Generates exe file. Okay, so by linking all of this in generating exe file. It generates exe file. Right? By linking all of this generating exe file. So that exe file linked with Windows OS library. Okay, suppose same program, yes, same C on Linux base. Another example, Linux base. Yes, C program exe file prepared on Linux base. C program exe file prepared on Linux base. Then it contains, yes, binary code for C program, binary code for C library. Next, binary code for, yes, Linux base library. Linux base library. Linux base library. Yes, let us see our Linux also. Linux. See, Linux you can see clearly. You can understand very clearly that how that exe file creating, how it's working here. Now in Linux you can understand very clearly. See, Turbo C, behind of this compiler generating object file. Next, behind of this compiler creating exe file. So everything happening automatically. So backend. So backend automatically it's happening. It's happening automatically. Yes, in Linux, yes, you have to do everything manually. Linux, everything is manually. Linux, you have to do all manually. Linux, you have to do manually. All of these things you have to do manually here. Okay, Linux manually. Now let us see. So manually compilation, manually creation of exe file, and linking on all this manually here. Yes. Now can see, you can understand very clearly here. A Linux you can understand very clearly. Yes, Linux terminal is Linux terminal, Linux terminal, Linux terminal. PWD means present working directory. LS means list of files, list of files. See, you guys don't think about Linux base. Our topic is not about Linux base. Our topic is about exe file. Okay, here in Linux, I'm using commands like pwd, ls. So you don't worry about these commands. Our topic is not Linux commands. Our topic about exe file. Our topic is about exe file. Now here mnr is a directory. Change of directory cd. Yes, like a Windows command prompt here also same command cd change of directory cd mnr changed present working directory mnr and its contents. Say this here C program is already available. Okay, 1 second. Let me delete all the existing one. T star, yes, T star star dot two, right? ls ls. Okay, so test.c file is available. Test.c. Now zread test.c, zread test.c, zread test.c. Okay, yes, open that. See this. Yes, here hash include stdio data center file. Yes, here also same program. Int a equal to 10, b equal to 20, c equal to a plus. So displaying addition, next subtraction and multiplication. Subtraction multiplication. Okay. Yes. Now here ls. Yes. gcc hyphen c test dot c. gcc hyphen c test dot c. gcc hyphen c test dot c means yes gcc or cc also you can write. gcc not necessary. That is yes cc compiler. CC means C language or GCC also anyone you finish. Okay, GCC, CC, it's a old compiler. GCC is a new compiler. Yes. So hyphen C test.c, just only compilation. Hyphen C means compilation. Test.c, C program compiling. Yes, compile no error, no error. Now what's results? Test.o means object file created. Same like Windows base. See Windows base here in Turbo C, generating one object file, test.obj file, test.obj file, test.obj file. Like this here also, test.o object file generates. Here are same object file generated. Now this test.o file can binary code for C program, binary code for C program. Right? No. Yes, GCC. Yes, hyphen O test dot. Yes, sorry. Yes, first project folder, project file. Sorry, project file. Test dot O. Test dot O. Now project is a result name. This name can be anyone. If project is a result exe name, it's a result exe name. ls. Yes. Create exe file. Project exe generated. Here green color means Linux. Green color means that is exe file. It's exe file. Project exe file created. Now let us run it. Yes, I'm running project exe file. See that? Addition, subtraction, and multiplication. Addition 30, subtraction minus 10, multiplication 200. So this exe file. Okay. Yes, like project you can use any name here. Project in place of project here. Some name ABC also you can use that name. Result exe name. Result exe. Result exe dot yes ABC right. Not dot slash ABC to run it. See that addition, subtraction, multiplication. So they are exe files. Now what happens here? C compiler, C compiler. Okay, yes. Hyphen O means object linking all the object files. Hyphen O means linking all the object files generating exe file. See hyphen C means one is compilation option. Hyphen C just a compile option. Hyphen C compile option. Compile and object file generated. Now this is to create exe file. This is to create exe file. Okay, now GCC compiler taking test.o means binary code for our C program, binary code for C program plus binary code for C library. Yes, here also stdio data center file included. Binary code for yes your program, binary code for C library. Yes, next binary code for OS library. By linking all of these things generates exe file. By linking all of these things generating exe file, that project exe file generates here. OS Linux OS library. Okay, now what happens here? A C program exe file prepared Linux OS, then it contains binary code for C program means the test.o file, test.o file. Okay, right? Yes, next binary code for C library means stdio data setter file binary code. Stdio data setter file binary code. Binary code for Linux based library. Yes, let me show that Linux based library. Yes. See, first of all, yes, about exe file. Yes, project is exe file. Exe file contains what binary code. Binary code. Let us see binary code. Let me show the binary code. Grit project exe file. Binary code. Let us see that binary code. Yes, it will take little bit time to open. Yes, series machine language. It's a binary code. System understandable language. Binary code. Machine language. Completely machine language. System understandable language. Okay, it's a system understandable language. It's a binary code. So binary code. It's a binary code. It's a binary code. Okay, that project exe file contains binary code. It's a binary code. It's a binary code. So this is binary code. So this is binary code. Okay. Yes, it's a binary code, right? Now, so this project exe file contains what exactly here? See here, Linux is a file command. Linux is a file command to check the type of the file. Linux is a file command. File command to check the type of the file. See, file, support test.c. I'm checking test.c file. So what is test.c file? Test.c. Test.c source ASCII text. C source. A test.c C source file means C code, C program code. ASCII text. It's ASCII text. Now, file command. Let us check about project file here. Project file series. Project. Yes, about project file. Yes, it's a executable file means exe file. It's exe executable file. Okay, correct? Yes, next prepared on Linux base. Yes, executable file prepared on Linux base. Which version this is? Okay, correct? Next here ld-linux x8664.s42. What is this one here? What is this? What is this? Yeah, this is the voice. Yeah, this is voice dot s42 is an extension to voice library. Linux voice library. It's a Linux voice library. So this is Linux voice library. It's a Linux voice library. It's Linux voice library. It's Linux voice library. Okay. So this exe file contains what? Here Linux voice library. Fine. Yes, Linux voice library. Yes, it's all the embedded C concept. Yes, in Linux there is embedded C concept here. That embedded C. Yes, it's a Linux voice library, right? Fine. I think you understand here. So that project exe file contains binary code for your C program is test.o file, binary code for C program, binary code for C library, and binary code for Linux voice library. That is also linked generated exe file. That is finally exe file. Okay. C program exe file prepared on Linux base. Then it contains binary code for C program, binary code for C library, binary code for Linux based library. Yes, let us try one more example. Let us see one more example. One more example. Suppose C++. No C++ program exe file prepared on Windows base. Prepared on Windows base. Windows base. Then it contains binary code for C++ program, binary code for C++ program. Next, binary code for C++ library, binary code for Windows OS 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 library. Now, in these three cases, what is common point here? These three cases commonly, yes, OS library. These three cases, OS library coming to picture, right? OS library. Okay, right? So what is happening here? Exe file, always exe file. Exe file always links with OS library. Exe file always links with OS library. Okay, exe file always links with OS library. Okay, exe file always linking with OS library. Exe file always links with OS library. Okay, So exe file always linking with OS library. So here exe file always linking with OS library here. Exe file always linking with OS library. Okay, if it is create on Windows base links to Windows OS library. If it is exe create a Linux base links with Linux base library. Okay, right? Suppose for example test.exe file. For example test.exe file. Yes, prepared on Windows base, Windows base, Windows base. Then 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 it links with Win library links with Win library. Okay, linking means nothing but just plug in. It becomes part of the exe file. Windows library. Okay. Yes, C compiler taking Windows library, C compiler taking Windows library, and we insert into exe file, inserting into exe file. Okay, that Windows library becomes part of exe file. Okay, test.exe file prepared in Windows base, then it links with Windows OS library here, Win library. So Win library becomes part of that exe file, it becomes part of exe file. Okay, becomes part of exe file, becomes part of exe file. Okay, right? Yes, now so test.exe file with Win library, yes, working on different platforms, working on different platforms, working on different platforms. Okay, test.exe file, test.exe file with Win library, test.exe file with Win library working on different platforms. Test.exe file, yes, with Win library working on different platforms. So test.exe file with Win library working on different platforms. Let us take different platforms here. Different platforms. First, let us take Windows platform. Let us take Windows platform. See Windows platform. Windows platform. Okay. Yes, computer. Yes. Yes, on computer. Yes, your computer. Yes, hardware. On top of it, who is right? On top of it, operating system. Operating system. On top of it, operating system. Yes, hardware. On top of it, OS. Okay. Yes. On top of OS, yes. Programs running right. All the programs. Okay, all the programs running right. On top of OS, all the PS. Previously, we discussed same concept. At the beginning, we discussed it. Okay. Hardware on top of OS, this is OS. Now it's a Windows OS. Yes, Windows OS. Windows, Win OS. Yes, Windows OS. Windows OS with Win library. With Win library. Windows OS with Win library. Right, okay. Yes, on top of it, test.exe file running. Okay, right? Yes, hardware. On top of hardware, this Windows OS with Win library here. On top of it, exe file running. Exe file. Okay. Now here, see this. Test.exe file with Win library working on different operating systems. Test.exe file. Now this test.exe placing on this Windows OS. When you try to run it, what happens here? Now this exe file. Yes, it will try to call to Win library. It will try to call to Win library. It will try to call to Win library. Okay. So when you run this test.exe file, yes, it will call Win library. Just it's calling Win library. It's calling simply. It's calling Win library. Yes, reason test.exe file all are linked with Windows OS library. Since exe file already linked with Windows OS library, it will try to call Windows library. Yes, here it's available. Here it's available. Just it's calling Windows OS library. Yes, available. Using that library, it communicates with hardware components. Fine. So successfully finishing. So this is yes on Windows OS. Same exe file on Linux OS. When you run on Linux base, what happens here? Okay. Yes. Not test.exe file. Yes. Same test.exe file on Linux base. On Linux base, what happens? Linux base with Linux library. Linux base with Linux library. Yes. What happens here? Now get test.exe file. Yes. It will try to call Win library. Test.exe file. Yes. Here also on Linux base also it will try to call Windows base library, but here is not available. So library is mismatch. It's not matching it. Library is not matching. Library is not matching. That test.exe file, it will try to call Windows library. It will try to call test.exe file, it will try to call Windows library, but here is not available. Since library is not available, simply fails. Simply fails cannot. Yes. See, Windows based exe file with Win library. Test.exe file with Win library. So when you're running on Windows OS here, it will try to call Windows library. Yes, available. Using that library communicates with the hardware components. Same exe file if you're running a Linux OS. On Linux OS also it will try to look for Windows OS library but not available. Simply fails. Simply fails. Okay, let us take another platform. Another platform, Mac. Mac. Yes, Mac OS. Mac OS. Mac OS with Mac library. Mac OS with Mac library. Mac OS. Mac OS with Mac library. Now what happens here? A same test.exe file if you're running on Mac OS here. Now this exe file it will try to call Windows library, but here is not available. Library mismatching, not available. That library is not available. Simply fails again. Right? Okay. So that exe file is OS dependent, right? Reason because of library here. Because of this library. Because of this library. Okay. So OS dependent. So exe file contains OS library. See, that library, once exe file created, that library's link is fixed. Yes, test.exe Windows OS library, test.exe file prepared Windows OS, then linking with Windows OS library. Okay, yes, that link is fixed. That link is fixed. That link is fixed. Okay, see exe file, statically, exe file, statically, yes, statically linking with OS library, linking with OS library. Okay, linking with OS libraries. Exe file statically linking. Yes, what is statically linking? I'll explain. Just wait. Once dynamically linking expand, you can understand statically. Once dynamically linking expand, you can understand statically linking. So exe file statically linking with OS library. Okay, static means fixed. Once linked, never changes that link. Once linked here, that never changes. Okay, test.exe file with Windows OS library here. So that exe file linked with Windows OS library, that link is fixed. That Windows library. So test.exe file, yes, with Win library, it's a fixed. That link never changes, a fixed. So that is nothing but static linking. Okay, yes. So exe file. So since exe file statically linking with OS library, it's a OS dependent. Yes, 1 second. Still, I think some confusion is there. What is static linking? Still confusion is there. So once dynamical linking clear, you can understand this one also. Dynamical linking, that has to clear. Once that is clear, you can understand this also. Okay, yes. So here why? Yes, exe file is OS dependent. Yes, reason. Yes, it contains OS library. It contains OS, simple reason. It contains OS library. It contains OS library. It contains OS library. Okay, exe file prepared on Windows OS, then it contains Windows OS library. If it is Linux OS library. Since exe file contains OS library, it's a OS dependent. It's a OS dependent. So about exe file. Now let us see about dot class file. About dot class file. About Java dot class file. About Java dot class file. How the dot class file is working here. About Java dot class file. About Java dot class file. About dot class file. About dot class file. Java dot class file. Java dot class file. Yes, how it's working. About Java dot class file. See, Java program. In Java don't have exe file. In place of exe file, it's a dot class file. It's a dot class file. Java dot class file prepared on Windows OS. Java program dot class file prepared in Windows OS. Then it contains binary codes, not binary code is a byte. Java everything is byte codes. It's byte code for Java program. Okay. Java program dot class file prepared on Windows OS. Java program dot class file prepared on Windows OS. Java program dot class file prepared on Windows OS. Then it contains byte code for Java program. Next, byte code for byte code. Yes, byte code. In Java, everything is byte code. Byte code for Java library. Java library. Java library. Byte code for Java library. Next, what? Binary code for OS library. No, don't have this part. Don't have this part. Java program dot class file. See, Java program dot class file prepared in this way. Java program dot class file prepared in this way. Windows OS. Then it contains byte code for Java program. Byte code for Java program. So byte code for Java library. Byte code for Java program. Byte code for Java library. See, Java library also developed in Java. See, Java library also developed in Java here. Java library also developed in Java. Right, okay. So finally, it's a purely Java code. Java library, C++ library developed in C++ language. C language library developed in C language. Python library developed in Python language. Java library also developed in Java here. Java here. That's it. That means it's a pure Java program. Yes. So dot class file is a pure Java program. Yes, pure Java program. Yes, in byte format. Pure Java program byte format. So dot class file here dot class file. So dot class file here dot class file is a pure Java program. So dot class here dot class file. Dot class file is a pure Java program in byte format. So dot class file is a pure Java program byte format here. Yes, it don't have any OS library. 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 It is free from OS library. Free from OS library. It is free from OS library. Free from OS library. Free from OS library. Okay. Yes. It don't have any OS library. So dot class file don't have any OS library. Yes, it is free. It is free from OS library. It is free from OS library. It is free from OS library. Right? Okay. Yes. Now, suppose for example here, test dot class file. For example, test dot class file prepared on anyways. Prepared on anyways. Don't have library. Don't have library here. Don't have OS library. Yes, prepared on anyways. Dot class file, tested dot class file, prepared on Windows OS or Linux OS or Unix OS or Mac OS. OS can be anyone. But don't have OS library. Don't have OS library, right? Don't have OS library, right? Okay. Now, so the tested dot class file. So tested dot class file is working on different platforms. Let us see how it's working on different platforms. Different platforms. Okay, different platforms. Tested dot class file. See, tested dot class file working on different platforms. Tested dot class file working on different platforms. How it's working on different platforms. Okay. Yes. Now let us take same that platforms here. Yes. Windows platform. Yes. Tested dot class file now running on Windows platform. How it's working. Now tested dot class file. Yes. Now this dot class file. Now can I run this dot class file directly or not? If this tested dot class file running, can I run it or not? 1 second. See. In OS, we have discussed about one point here. See, every program has to link with OS library before going to run it here. Otherwise, cannot communicate with hardware. Yet to communicate with hardware, here. Yes. So every program has to link with Waze library. Every program has to link with Waze library. It has to link with Waze library before going to run. It has to link. So every program has to link with Waze library before going to run here. So all the programs linking with Waze library. So all these programs have to link with Waze library. Okay, all these programs linking with Waze library, then execution, right? It has to link. But when come to Java.class file, it's not linked. Java.class file is not linked, but it has to link. Then how? So it won't run .class file, won't run directly here. .class file cannot run directly. This .class file has to link with Waze library compulsory. Every program has to link. So even this .class file also has to link with Waze library. Who will link it here? Yes, for linking purpose between test.class file and OS, one more layer come to picture. One more layer come to picture. So one more layer. So one more layer will come to picture. Yes, what is this layer? Anyone can guess it? What is this layer? Anyone can guess it? No. Yeah. Tell me. Yeah. Actually, I mean, can you call back again? Yeah, it 12:30. Yes. Now between test.class file Windows space, there is a one more. Yeah, that layer is a JVM layer. JVM means Java Virtual Machine. JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. Okay. So what happens here? Yes, JVM taking your test.class file. JVM taking test.class file links with Windows OS library. See JVM here, JVM taking test.class file. JVM taking test.class file linking with Windows OS library. Once linked here, communicates with hardware. Okay, right? Yes. Next, let us take another platform. Let us take another platform. Another platform. Let us take another platform. See another platform. Yes, suppose Linux base. Linux base. Linux base. Linux base with Linux library. Linux base with Linux library. Linux base with Linux library. Okay. Yes. How it's working? On Linux base, here also JVM. Yes, that Linux JVM taking test.class for links with Linux library. So once linked here, executes that here. Now let us take another platform. Yes, macOS. 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 Same .class for running on macOS with Mac library. Then on macOS there is here JVM here. Now this Mac JVM taking test.class for links with Mac OS library here. That's here. So what is happening here? Every time of changing OS, same test.class for running on Windows OS, running on Linux OS, running on Mac OS. Same file is no change. Same test.class for running on different operations. Okay. Yes, if it is running on Windows OS, linking with Windows OS library. Okay. Same test.class for if it is Linux running a Linux base, Linux JVM links test.class Linux base library. Same test.class running on my Mac base. Then so the JVM links test.class for with Mac library. That's it. So every time of changing base, that link changes. Every time of changing base, that link is changing, right? Link is changing. So this is called dynamic linking. Dynamic linking means at runtime. At runtime, yes, runtime linking to Windows OS library, then execution. Yes, a runtime linking to Linux base, then execution. Yes. So here runtime links to Mac OS and execution, right? So dynamically means the runtime changing dynamically. So that dynamic means changes. Dynamic means changes. Dynamic behavior means what? Depends on situation that behavior changes. Same. Now it's a dynamic linking. Okay, Java dot class file is dynamically linking with OS library by the JVM. It's a dynamical linking. See, what is C language? When come to C language, exe file. Suppose exe file prepared in Windows file, then links with Windows OS library linked. That link is fixed. That link is fixed. Okay, that link is fixed. Okay, exe file running on Windows OS. Yes, it can work. Same exe file when I try to run a Linux OS, it fails because that is link is fixed. That library link is fixed. It's a fixed. That is called a static linking. It's a static linking. Static linking. That link never changes. At the time of creating exe file itself, linking. At the time of creating exe file, linking. That is nothing but statical linking. Okay, that OS library statical linking with yes exe file. Since exe file statical linking with OS library is OS dependent. When come to Java here, Java, every time of changing OS that link changes. Every time of changing OS that link changing, link changing, link changing. Right? Every time of changing OS that link changes. It's called dynamic linking here, right? So dynamic linking. Okay. Yes. Since Java dot class file dynamically dynamically yes linking dynamically linking since Java dot class file dynamically dynamically linking with OS library since Java dot class file dynamically linking with OS library. Yes, it is an independent platform. It is an independent of OS. Anyone can say independent. Independent. Yes, independent of platform. Platform. Yeah, that's the reason here. How Java made us independent of platform? Okay, since Java dot class was dynamically linking with OS library by the JVM. This is by the JVM. So JVM is the responsible, right? JVM is the responsible to make Java is independent of platform. So every time of changing OS, that link changes. Okay, every time of OS, yes, every time of changing OS, yes, link changes. Every time of changing OS, here link changes. Yes, link changing by the JVM. So it is called as dynamic linking here. Okay, every time of changing OS, every time of changing OS, link is changing by the JVM. Yes, it is called as dynamic linking here. It is called as dynamic linking, dynamically linking. It is called as dynamic linking. It is called as dynamic linking. Right? Since Java dot class for dynamically linking with OS library by the JVM, it's an independent platform. Okay. See, anywhere statically linking is a OS dependent. Just remember this. Anywhere statically linking is a OS dependent. Okay. So dynamically dynamically linking, yes, dynamically linking is a OS independent, OS independent, OS independent, OS independent. That's it here. Okay. See, Java and Python, both, yes, both dynamically linking. So both are dynamically linking. Okay. So dynamically linking with OS library. So these are independent platform. Okay. So even Python are independent platform. Java and Python both are independent platform. Reason dynamically linking. Okay. Scenario where statical linking. Generally exe file. Exe file is a statical linking. That is OS dependent. Okay. Yes, a dynamical linking is a OS independent. See, Java program dynamically links with OS library is independent platform. Yes, Python scripting also dynamically linking with OS library independent platform. Okay. Yes, so they about independent platform. Okay, right? Yes. Now here's some doubt here. You guys may be getting some doubt. You guys are getting some doubts. I think you have doubts. See here, I'm seeing that if dot class file running on Windows OS, Windows Jvm linking to Windows OS library. Same dot class file if it is a Linux OS, Linux Jvm linking dot class to Linux OS library here. Okay. Yes, same thing if it is a Mac OS linking to Mac library. Mac library, right? Mac library. Okay, right? Yes. Now question is, yes, JVM is it part of OS? That may be doubt. JVM is it part of OS? No. JVM is not a part of OS. JVM is not a part of operating system. JVM is not a software. It is from JDK software. It is from JDK software. Okay. JVM is not a part of OS. JVM is not a part of OS. It is from JDK software. Okay, right? Yes. So then how can you get JVM here? Just to get JVM. Yes. To get JVM. Yes, we should install. We should install. Yes, we should install JDK software. We should install JDK software. We should, once JDK software installed, we can get the JVM. To get JVM, we should install JDK software. That's it here. So it is from the JDK software. It is from JDK software. So JVM from the JDK software. Okay, once JDK install, yes, getting JVM automatically. That installation tomorrow topic. Tomorrow I'll show. After installing JDK, how the JVM getting, where is JVM is available. In tomorrow class, I'll show that. Tomorrow class. Okay, right? Yes. Next, one more interesting point here. See, Java.class file. Java.class file is an independent. Yes, independent of OS. Okay. Java.class file is an independent. Okay. See, Java.class file is an independent of OS. See, Java.class file is an independent of OS, but JVM is a OS dependent. JVM is OS dependent. Okay. So see this Java. Interesting point here. Java program is independent of OS, but JVM is OS dependent. JVM Java virtual machine is OS dependent. Reason JVM. Yes, JVM developed in C++. That's the reason. Yes, if it is developed in C++, is exe file. In C++, everything is exe file, right? Finally, it's exe file. So JVM is a C++ exe file. C++ exe. That's the reason why it's dependent. JVM is a C++ exe file. Okay. See, Sunsoft has developed. Okay, Sunsoft has developed. Yes, JVMs for every OS in the market. Every OS in the market. Okay, Sunsoft has developed JVMs for every OS in the market here. Every OS they have developed. Okay, right? Yes, now here. So about JDK software. See, JDK software. See, yes, JVM is OS dependent, right? JVM is OS dependent. Okay, yes, JDK installing and Windows OS. So that Windows JDK must have Windows JVM, right? That JDK must have Windows JVM because JVM is OS dependent. Okay, suppose JDK installing Linux OS. That JDK also must have what here? Linux JVM, not Windows JVM. Okay, JDK for Windows OS, JDK for Linux, JDK for Windows OS must have Windows JVM, JDK for Linux OS must have Linux JVM, JDK for Mac OS must have Mac JVM. So JVM changes, right? Since JVM changing, automatically JDK also will change. Same JDK cannot be installed on all different operations here. Same JDK cannot be installed. So for every OS, separate JDK required here. Since JVM is a OS dependent, JDK also OS dependent. See, Since JVM is a voice dependent, voice dependent. Since JVM is voice dependent, JDK also voice dependent. JDK also voice dependent. Okay, right? So JDK also voice dependent. That means same JDK cannot be installed on different applications. Same JDK cannot be installed here. See this. For example, C drive. Yes, in my system, the JDK for Windows OS I will write JDK Windows 64-bit. JDK Windows 64-bit. Yes, now this JDK working on only Windows OS. Cannot run on Linux OS. For Linux purpose, you have to download another JDK. Another JDK. 1 second, let me show that. Downloads JDK 1.8 series. JDK 8 downloads. See, these are all downloads. JDK downloads. All the downloads. See this Linux. This is Linux JDK. Linux JDK. Yes, next this is Mac JDK. See why these much of things in Linux there are different flavors. Linux there are different flavors like Ubuntu Linux base, Red Hat Linux base, like different. Okay, see RPM. This is for Red Hat. RPM Red Hat Pack Manager. RPM is Red Hat Pack Manager. So this is for Red Hat Linux base. So wherever .rpm is, that is Red Hat Pack Manager. Right? Okay. Yes. Next .tar.gz. This is for Mac OS. This is for Mac OS. Okay. .tar.gz Mac OS. Sorry. Ubuntu Linux. So this is for the Red Hat Linux. This is for Ubuntu Linux. Yes, next .dmg. This is for Mac OS. This is for Mac. Okay, see Linux. They are Linux. This software is for Linux OS here. The JDK for Linux OS, JDK for Mac OS, JDK for Solaris. JDK for Solaris. Okay, next JDK for Windows OS. So JDK for Windows OS. Okay, so different JDK for different operations. Depends on which the JDK changes. Right? So JDK depending on OS here. I think clear, right? So this is about yes, exe file in dot class file. Since exe file statical linking, it's a OS dependent. Yet dot class for dynamic linking, it's an independent platform. That's it. So that's all about independent platform. See, same thing explain document also. In document, yes, exe file and dot class for differences. See that exe file dot class for differences. Exe file dot class. What is first difference? Binary code. Exe file is a binary code. Dot class is a byte code file. This is first difference. Okay, binary code file and byte code file. Okay, right? Exe system understandable language directed, but dot class is what JVM understandable language. That byte code is a JVM understandable language. Okay, right? See exe file. It contains program code, a software library, and OS library. Exe file contains OS library, a dot class file. It's a pure Java program in byte format. Don't have OS library. That's the difference here. So dot class file with OS library. Dot exe file with OS library. Dot class file don't have any OS library. Right? Okay. So this is main difference. Exe file dot class main difference is exe file contains OS library. Dot class file don't have OS library. Okay. Next, see exe file. OS library statical linking with exe file. OS library statical linking. Yes. Java dot class file. So OS library dynamical linking. So dynamical linking, right? Dynamic linking. See, exe file is already prepared. Only one time preparation. Exe file only one time preparation. Dot class file every time of changing OS, that link changes. See, exe file only one time linked with OS library. Exe file only one time linking with OS library means it's a prepared. Exe file is a prepared, but dot class is not a prepared. After moving on to OS, JVM prepares as per current OS. If it is running on Windows OS, links to Windows library. If it is running on Linux, links to Linux OS library here. That is preparing simply here. But exe file is already linked, prepared one here. So the difference here. Exe file dot class file. So first difference, exe file is a binary code file. Next difference, exe file is a binary code. Dot class is bytecode. So next difference, exe file gets OS library. Dot class file don't have OS library. Next difference, static linking, dynamic linking. Yes, exe file static linking. Yes, dot class file dynamic linking. That's it. That's it. Okay, so this is difference between exe file and dot class file. Okay, right? So exe file dot class. So that's all about independent platform. Okay, independent platform. Yes, with this all this Java introduction completed. Java introduction and the software fundamentals Java introduction all are completed. So next topic is Java installation. Yes, tomorrow going for Java installation. Okay, tomorrow going for Java installation. Okay, JDK software for installation, JDK software required. JDK software again Eclipse. Tomorrow we'll discuss about yes how to install JDK Java software and how to install Eclipse. That all these setups we'll discuss. After that, how to develop first application Eclipse also we'll discuss. Tomorrow topic all the setups and installations. Yes, any doubts? Yes, guys. See, already Google Drive access given. Google Drive access given to many guys. This means yes, like paid members. Frankly speaking, yes, paid for all fees paid members, the drive access given. So who got the drive access? Who paid? They will get the drive access here. Already given as per online team. As per online team, yes, email ID is here. I have given drive access to all fee paid members here. Okay, correct? Yes, in Google Drive, yes, material is available, next software available, and all are available here. All are available, you can access. Go to your Gmail. Okay, go to your Gmail. See, first log into your Gmail. Suppose let us say this login Gmail. Yes, here Google Apps. Yes, Google Apps. Here there is a Google Apps. In Google Apps, Drive option. Drive option. Okay, next here shade with me. Shade with open shade with me. You can see everything here. Shade with me. Yes. Suppose let me log in, new login. 1 second, for example, new login. Yeah, I don't know that much. Suppose login. Suppose okay. This is the login. So for example, this is your login. This is your login. Login ID. Login ID. Next password. Password. Yes, after login. After login. Next step is here. There is a apps option. Google Apps. Top corner. Top corner. Google Apps option is available. Yes, open here. There is a drive option. This is a Google Drive. Drive option. Open the drive. Open the drive. Yes, here shade with me. Shade with me. Shade with me. Click on the shade with me. Shade with me. Shade with me. Shade with me. Yes, here you can see mnref folder folder. Yes, this is with all documents. See this JDK documents. Next, your class document. Next, Eclipse. JDK software. Your class document, Eclipse software. Next, there are other materials. Other materials that we'll see next. Other materials. Now, initially, you have to download JDK software, Eclipse software, and your class document. That's it here. Next, in shade with my recordings. Recordings, yeah, recordings. Okay, recordings. Yes, you can see recordings folder. 1 second, recordings folder. Yeah, this is recordings folder. No, it's not this one. Sorry, not this one. 24. Yeah, this is your recordings folder. Yes, recordings folder. Recordings. Here, this is your screen. One second. Recordings. One second. Recordings. Drive. 15. Yes. Drive. Drive. Here this is. Jvm course of 7:30 AM IST. So this is your recordings folder. This is for records. So Jvm course of 10:30 AM IST. Here it's available. See, I'm sharing this access like this. Like this access. Okay, now you can go to the drive here. This is, yes, Google Drive. Yes, after login to your Gmail, go to Drive. After login to your Gmail, go to Drive here. Go to Drive. From the Drive here, there is shade with me option. Shade with me option. Shade with me option. Shade with me. See MNR 10:30 AM. Yes, you can see. Open that folder. You can see all that. Yes, 4 recordings. Till yesterday's recording. All that you can see. All that you can see. 4 recordings. So recordings folder. Okay. See. First log into your Google Gmail, then go to Google Drive. Here Google Apps option at the top corner. Google Apps option. Drive. Open the drive. Google Apps from the drive. In drive, shade with me. Here they shade with me. Shade with me. Here you can see recordings folder. MNRA course out 10:30 AM. The recordings folder. Okay. Next again back to this. See MNRA course documents folder. It's a documents folder. These documents. Documents folder. From this you can download. Yes, tomorrow we'll do all of these things. Tomorrow, yes, we are going for installation. By tomorrow, ready with your all the softwares. By tomorrow, ready with all the softwares, we'll go for installations. Yes. Any doubts? Yes, case, any doubts? Yes, no doubts, let us wind up session for today. If no doubts, let us wind up session for today. So thank you guys. Thank you guys. See you tomorrow.